Hello, IED crew. Just in case this is a little overwhelming, I'm going to go through and record week 8. So if you go ahead and look in resources, you'll see cams make the world go round. So we're going to talk about cams, and we're just done the pre-test and all that jazz. So the next steps are basically to go through everything that was on that pre-test, starting with cams. So you'll see the weekly plan here. We're going to go over this, talk about cam creation, which is basically recreating the default kind of cams in Onshape. And then we're going to talk about animation on Thursday, Friday. So again, just walking through this, what are cams is the very first kind of section. Talk about the parts of the cams, how they actually function, what they look like, some examples of real life, systems that use cams. Stole the Project Lead the Way video that walks through what a cam is, the parts, that goes through a lot more detail than what I do. I wouldn't go through the whole entire thing because it can talk about the graphs and the you making your own cam, custom cam, and the motion studies and all that jazz. So I would stop it at 115. That's what I plan to do. Next thing is the cam types and movement. So these are just the 6 types of cams, creating different types of motion. I walked through in cam types here. I think I stole the Project Lead the Way video here. Cam movements here. I basically sectioned and used a section view along with an animation in Onshape to show the different variations and different motions that the cam types create. And then the cam creation activity is pretty straightforward. Basically, they're going to be given a PDF with this, with all 6 of the cams, and all they have to do is recreate them in Onshape individually as parts. The through hole should be a square, not a circle, as demonstrated inside of the doc here. So you'll see through hole should be a square of 0.26, just to give that tolerance and that clearance for the axle itself. And then the diameter, or D, equals 1.5. So you'll see a lot of here, nominal denominator here, or diameter here, D, divide by 2, divide by 8 here, gives you those answers. And through what I've done with Onshape as far as the assembly and the automata, eventually found out that it is the 1.5 inches. So just have the students use that as a reference. And that's it for that. So you'll see cam dimension drawings. Again, like I just said, it's the PDF version of all 6 of those cams. Have them recreate them, and again, D equals 1.5 inches. Wednesday is a work day, just going through and working on those cams again. Thursday, Friday is animation. So if I open this up, you're going to see basically we're starting to talk about the different types of animations that we're going to focus on. I don't go through them all, but I just first off talk about the mechanisms in motion and talk about what motions are needed to express and why we even use them in engineering and within systems here. So we're going to talk about mechanisms in motion. So when assembling models in Onshape, it's just important to just talk about why they would even use, why anybody uses Onshape or animation in any software. Kinematics talk about the study of motion and just how certain things should move appropriate. Talk about analysis of motion within a system, and this will include gear rotating, sliding mechanism moving, axle twisting, etc. So these are just going through those systems. Mechanisms in motion again. So these are the different features that we use. They're called relation features, and they allow multiple mates to interact with each other. And that's how Onshape uses driven constraints you guys might be familiar with. So in order to achieve an animation, you'll need to make sure you use the correct mate first, and that's the really important part, and then a relation feature to simulate the motion of those mates. And then we go over those relation features. There's a gear relation and there's a rack and pinion feature. And again, rack and pinion looks like this. It's pretty straightforward. You can show whatever you want there. I show a little animation here of the gear relation, and I show you how to do all these. So I've made 3 walkthrough tutorial videos, and I highly recommend you guys watch these on how to make these systems here that you see. Again, I give all the parts in Onshape. I've already given access to everybody the parts, so all they have to do is really assemble this first. They don't have to draw all these pieces, obviously. They assemble them all, they constrain them all with joints, the proper joints, and then they use those relation features to animate the systems. I don't have a belt for the pulley system, just kind of highlight that. It's really hard to make one of those. And then the worm gear system. So they're going to be making all 3 of these, and that kind of is a good segue into the animation activity. So basically, in order to practice, they're going to make these things. They're going to use those VexIQ parts, as you see here, to make all 3 of these. So they're going to find the correct parts. They're going to, in all company users, they're going to assemble them. They're going to add the correct relations after they make the mates. Right click on the Revolute. And again, all these 5 steps are inside of these 3 tutorial videos that walk through how to even assemble these things, how I offset some of these things, every piece of the puzzle to get this animation, these 3 animations to look like this, I show inside of the spur, the videos, the pulley, the worm, and the spur gear. So that's all I have for this week. If you have any questions, as always, just ask. Thanks, guys.